Hi, 6th graders. We are on lesson 2 this week in your book. It starts on page 19. And I just wanted to remind you that this family letter at the front, yes, it's good for your parents to read it, of course, but it also has a lot of the information you need on what we're doing. It basically has the entire lesson on it. So this week we are finding the area of triangles and other polygons. You know what a triangle is, obviously, but let's refresh on what a polygon is. Polygon is a shape. More specifically, it's a 2D shape. So it's a flat shape, and it has to have straight sides. So any polygon, so a triangle is a polygon, a square is a polygon, a trapezoid is a polygon, a star is a polygon. That's a terrible star, but you like it anyway. A circle is not a polygon. It has to have straight sides. A half circle is not a polygon. It has to have straight sides. This can be a polygon because it's all straight sides. This cannot be a polygon because one of the sides is round. So polygons are flat shapes that have straight sides. Okay? We are first going to go over how to find the area of a triangle, and then after we can find the area of a triangle, we're going to look at any other polygon that doesn't have a name. So if you look at this example down here, this one doesn't really have a name. It's just a crooked quadrilateral. Remember, quad means 4, lateral means sides, so it's got 4 sides. This polygon is just kind of a weird quadrilateral. I guess it's technically a trapezoid if you look at it. Yeah, it's a trapezoid, technically. But we're going to look at how to find the area of shapes like that. But first, after your parents have gone over the Dear Family letter, you're going to do this page right here, this little activity with your parents on your own time. But we are going to do session 1 right now, which is the area of a triangle, and this is the Explore activity. So ideally, you do the Explore activities on your own because it's just kind of you getting a chance to figure things out without somebody just telling you all the answers. So, now that I've said that, I'm going to proceed to just tell you all the answers. So try to do this on your own first. Use me as a helper after you've given it a try. So pause when you think you've got a chance to do this on your own. I will go over the first part with you right now. Caitlin has 2 decals shaped like triangles, the triangles shown. She arranges them on the back of her skateboard to form a parallelogram. So she's taking these 2 triangles and she's going to put them on her skateboard in a way that makes a parallelogram. Each grid square represents 1 square inch. What area do the 2 decals cover? And I want you to notice right here for Math Toolkit, it says you could use grid paper, you could use tracing paper, you could use unit tiles, so it gives you hints of the different things you use. Now I am using a digital device, so I do not have tracing paper. I'm going to have to do this kind of on my own. So, let's see, this goes 1, 2, 3. So I'm going to imagine I'm going to trace this, and then I'm going to flip it over to make this side meet this side right here. So it's going to end up being 1, 2, 3, and then over like that. So that's what it would look like if I were to trace over this and flip it over and stick it there. So now it's a parallelogram. And you know that the area of a parallelogram is the base times the height. The area of a parallelogram is base times height. So all we need is to find the base and the height and multiply them. You can find the height anywhere as long as it's perpendicular to the base you're using, so it makes a 90-degree angle. So the base here is 1, 2, 3, 4, 5, 6, 7, 8. 8 times 1, 2, 3. 8 times 3, which is 24. And don't forget, since it specifically said we're working with inches, we should add our units here, inches squared. So So the 2 decals will take over 24 square inches. Okay, looking back, what area do you think Caitlin's 2 decals cover? I think that's going to be 24 inches squared. And explain how you know. That's the important stuff here. This curriculum is very explanation based. So let's stop and think for a second how we can explain that. Well, when I put the triangles together to make a parallelogram, I was able to multiply the base times the height to find the area. There we go. And that's a good answer, so we deserve a smiley face. Alright, now that was looking back at the previous problem. Now let's look ahead to what we're going to be learning tomorrow. So this is kind of your prequel for tomorrow. As in a parallelogram, the base and the height of the triangle are perpendicular. Remember, perpendicular means, let's give ourselves a little reminder over here what perpendicular means. Perpendicular means they create a 90-degree angle. It's the opposite of parallel. So these two lines are perpendicular, all these 90-degree angles that they make. So it basically means they go the opposite direction. Any side of the triangle could be a base as long as you make the height perpendicular to that base. The corresponding height is drawn from the vertex at the opposite of the base. Okay, so in this one, they decide this is the base, so the height must be perpendicular to it. In this one, they decided to use this side as the base, so they just have to make sure the height is perpendicular to it. We're not going to do A right now. Use the triangle at the right. Draw the height that corresponds to the side labeled as the base. So here's the base. We just have to draw the height, then write the units for it. Okay, so here's the top, so we just have to create a line that goes from the bottom to the top. 1, 2, 3. I guess I don't even need to do the dots. I'm not going to do the dots. You could do the dots if you want to. So the base is how many units? 1, 2, 3, 4, 5, 6, 7, 8. And the height is 1, 2, 3. There you go. Okay, this one doesn't give you the units because it's not on a grid. All we need to do is draw the height. Now remember, you're supposed to be trying to do this on your own, so try to do it on your own before you see how I do it. But just in case, I'm going to do it anyway. Here's the base. Now the height, we can't just go like right there. That's not how tall it is. So you can do it from a few different ways. You can go out here and go up, or you can go out here and go across. So this would be the height in this case. Either way, we would have the height either as this line or this line. You could even go from the middle if you want. As long as you go from the base to the tip and straight up and down, you're good to go. Okay. For C, it's the same thing except this triangle is crookedy. So you could do this. You could use any of these. You can use anything as a base. Up to you. Let's see. I think the easiest is going to be this one because the height would be right here. So I can go straight from the middle over here. But I mean, you could have done it out here. You could, I'll do another one. You could use this base and this height. That one's easy too, I guess. As long as you go from a base and then you go perpendicular. Then draw the height that corresponds to the base. Label the base B, fine, B, and the height H. There we go. Okay, now time for some reflection, and then it's your independent practice pages. So look at the right triangle on the right, no less. And remember to refresh, it's called a right triangle because one of the angles is, we'll call it a perfect corner. It makes a 90-degree right angle. It's important to remember that one. Which pair of sides can be called a base and height for the triangle? Which two sides? So we want to stick with a pair of sides here. It doesn't want us to give another line for height. It doesn't want us to do that. It wants us to use the sides. So since it's a right triangle, if you look here, you could do, this is a base and this is a height, or this is the base and this is the height. Doesn't matter, does it? It's going to give you the same answer. And it says to explain that, so the sides that form, let's think how we explain it. The sides that form the right angle can be the base and the height because they are perpendicular. There we go. The sides that form the right angle, I think that's what I said. I already forgot what I said. The sides that form the right angle can be the base and height. I'll switch to cursive again. Stop doing that. Base and height because they are perpendicular. Look at all the space I'm running out of per pen. Do I know how to spell perpendicular? Perpendicular. I'm a math teacher, not a spelling teacher. I think that's how you spell perpendicular, for goodness sakes. Okay, so here are your green pages. This one's for you to do. Remember, parallelogram. Spoiler, here's your hint. There you go. This shouldn't be there. Don't draw that. Okay. And then, is this a polygon? Is this polygon a parallelogram? And then we will do lesson 2, session 2 tomorrow, which is a develop. And develop is not due on your own. Develop is due with a grown-up. So see you on that tomorrow.